What if a door existed in the universe that did not open? What if it looked, from a distance, like nothing more than a star gone dim, and yet it marked a boundary so absolute that crossing it would mean a passage into a state of reality where the usual rules of sight, of time, of return unravelled? That is the quiet horror and the sublime invitation contained in the phrase, "the door of no return." It is not a door in the architectural sense, it is a boundary in space-time, drawn by gravity so extreme that not even light can find its way back across it. A black hole, in the simplest terms, is a region of space where gravity is so intense that escape velocity exceeds the speed of light. This is the engineered bluntness of physics. Light, the fastest messenger the cosmos knows, stalls at the threshold. The boundary of this realm has a name, the event horizon, and it functions like a one-way membrane. For those on the outside, the event horizon is invisible until one crosses it. For those who cross, it is the last line of familiar physics. The image is cinematic, a dark sphere silhouetted against the glow of nearby gas, a moor in the starry fabric. To approach that boundary is to trade the comfortable narrations of everyday physics for two competing stories. One story is the external account. From afar, an approaching object seems to slow, to redden, and to fade, stretched thin by gravitational redshift and smeared by time dilation. To an outside observer, the infalling becomes a ghostly silhouette, crawling ever closer to the horizon but never quite crossing in finite proper time. It is a dissonant spectacle, motion that looks arrested, a paradoxical stillness wrapped in acceleration. The other story is the personal account, for the entity that actually the first sensation to be up and down vibes. The speculative mind grasps for is the stretching of scale. In the presence of a strong gravitational gradient, the difference between up and down becomes something measured in inches and seconds, not in continents and eons. Tidal forces, the differential pull that stretches matter, would in many cases act like a cosmic blender. For supermassive black holes, the experience is different. An object would elongate and then atomize, the process often invoked as spaghettification. The evocative term captures both the physical literalness, the body drawn thin, and the metaphorical stretching of identity into something. Time itself, space-time counterintuitive ways, near 6-time house side, 2-op, mass tie pluck, clock, slow wrist, signal ras. Time tells mass how to move. Clocks slow relative to distant observers. Signals are stretched into long reddened sighs. Signals are stretched into long reddened sighs. To someone far away, events near the horizon drift into an asymptotic dusk, approaching but never consummating, recorded as ever-lengthening echoes. Supernova, the time experienced along a world line, might march forward without pathological interruption, but the future it leads to is a region where lose their familiar meanings. The poet in the narrator. This philosophical unease deepens when the story turns to information. In a documentary told with speculative flair, the host might draw the listener in with a quiet, almost conspiratorial tone. What becomes of the information carried by anything that falls inside? Classical physics admires determinism. Given the present state and the laws, one can predict the future and reconstruct the past. Yet black holes, by their very definition, seem to obliterate the ability to reconstruct. In the 1970s, Stephen Hawking showed that black holes are not perfectly black. Quantum effects make them emit. This mismatch has echoed through decades of theoretical debate, a drama of its own set on the cosmic stage. Hypotheses have proliferated. Maybe the information is encoded on the event horizon itself, smeared thin like ink on a page, a notion that gave rise to the holographic principle. Perhaps it emerges encoded in the correlations of Hawking radiation, or perhaps our understanding of space-time must be replaced by something fundamentally quantum. Each proposal reads like the turning of a lock against an impossible key. Each suggests that the door of no return may not be absolutely final, but may instead be a sieve that There is an immediacy to mechanics, as on matics, as a species standing at the lip of comprehension. There is an immediacy to confronting a black hole that goes beyond the technicalities. It highlights smallness and temporariness. If one measures time in geological or cosmic units, human history collapses into a blink. If one measures mass and energy, human artifacts are dust motes against the abyssal scale of gravitational wells. In the telling of a speculative documentary, the narrator will not spare the listener this perspective. The Earth, with its layered sediments carrying the fingerprints of vanished species, becomes both fragile and resilient, a place molded by epochs of ice, where science shapes the speculative question posed at the beginning. If an astronaut, not a particular person, but a stand-in for human exploration, classical, what would the universe answer back? The answer is messy and layered. Physically, from the outside, the approach would be seen as an ever-slowing fade. Locally, there might be a direct and abrupt plunge. Conceptually, one gets different answers depending on the level of description. Classical general relativity promises a singularity, a point where curvature diverges and the equations break. Quantum gravity suggests that singularities are flags, signaling the incompleteness of galaxies, rashes, and erasers of cosmic memory. Over deep time, black holes will persist. Galaxies will dance, coalesce, and die. Stars will be born and sputter out. Matter will be fed into the gaping wells and sometimes radiate away in transient flares. In certain speculative frameworks, black holes could act as repositories for the energy and perhaps even the information of their absorbed contents. In more sober takes, they are cosmic graveyards where structure collapses into monotony. For storytellers of the documentary kind, this duality is fertile ground. On one hand, black holes could conserve traces in quantum hair, hints of a final image lingers in the voice of the narrator. The door that does not open is less a menacing trap than an invitation to humility. It asks the listener to accept limits without surrendering curiosity. Black holes are not merely endpoints, they are questions encoded into the cosmic ledger. They compel the seeking mind to refine its instruments and its theories until the door that once seemed absolute becomes a locus for deeper understanding. The boundary of no return, in other words, begets not resignation, but a more patient kind of longing. To face such a boundary is to... So the narrative returns to its opening provocation and reframes it. The door of no return exists, but its finality is measured in the human scale of comprehension. There may be practical novelties. The athlete of space-time is stretched, clocks misbehave, light grows pallid. But the deeper mysteries center on whether information is destroyed and how quantum gravity reconciles the two discordant tales we tell. The speculative documentary voice presses this point gently but insistently. The great drama of black holes is not only their physical aggression, but their capacity to expose the lacunae. In the end, the black hole is an idea as much as it is an object. It is a probe into the limits of what can be said, a crucible where geometry, quantum mechanics, thermodynamics, and philosophical notions of knowledge intersect and collide. To approach it mentally is to accept paradox, that the cosmos can be both comprehensible and forever withholding, that a boundary can be a teacher. The door of no return is therefore a hinge on which our sense of finitude swings. It offers no return for those who cross it, at least not in the simple ways previously imagined. Yet for the rest of us, it opens a space for questions: how would their time flow compared to ours? That single question opens a corridor of thought that runs from kitchen table curiosities to the coldest equations of relativity. It asks not merely how fast a clock might tick, but how experience itself would be stitched into the universe if placed in a different gravity well. It pushes the listener to imagine duration as a thing that can be bent, accumulated, and rationed, an attribute not fixed by habit or heartbeat, but by the curvature of space-time itself. At the heart of the answer lies a deceptively simple idea. Gravity changes the rate at which time passes. That is the kernel of Einstein's insight. The pragmatic, almost poetic way general relativity reframes gravity not as a force acting at a distance, but as geometry. Matter tells space-time how to curve. That curvature tells clocks how to tick. Explaining this in plain terms demands an image. Picture time as a wide, steady river. In ordinary places, the current flows at its usual pace, carrying boats, lives, histories, civilizations along the same direction. Place a massive rock into the river, and the water near that rock slows, eddies form, and currents distort. Close to the mass, the flow of time slackens. The more massive the rock, the greater the distortion. This is not poetry without experiment. Over the past century, physicists tested the idea that confirmed conformations were humble in scale but huge in implication. In one early experiment, physicists measured how photons shifted in energy when raised and lowered in a tower. A subtle weighting of frequency that confirmed clocks at different heights ran at different rates. Later, the Helvetica flights carried atomic clocks on jetliners and compared them to identical clocks that remained on the ground. Differences in elapsed time, minute, and imperceptible to humans matched relativity's predictions. Today, the global positioning system, the equations of relativity quantify the effect in a precise way, but the documentary voice need only dwell on the qualitative meaning. In a gravitational potential, well, the deeper the potential, the closer to the mass, the slower clocks run relative to those far away. If one clock sits quietly on Earth's surface and another orbits a few hundred kilometers above, the difference over a year is fractions of a microsecond, trivial for a human lifespan, but catastrophic for a satellite network that demands nanosecond synchrony. If, however, the same comparison is made against a black hole, the divergence. Two complementary narratives follow this single fact, and both are true in their own frames. From the outside, watching toward a gravitational abyss, processes near that abyss appear to slow and redden. Pulses of light are stretched to longer wavelengths, gravitational redshift, and to longer intervals. A signal that begins as a steady drumbeat becomes a distant, decelerating heartbeat, each beat moving further apart until it dissolves into the background. Measured spectrally, emission lines from matter spiraling at the inner edge of an accretion disk shift and smear, betraying that time in that region is being dragged apart. From the local perspective of whatever resides near that mass, subjective time feels normal. A precise, well-made clock keeps its own kind of time. A thought occurs, an atom vibrates, a chemical reaction proceeds without knowledge of any external stretching. That tension, normality experienced locally and distortion perceived externally, is a central paradox of relativistic time. It is less a paradox than a statement about frames. Physical processes are well behaved inside their own light cone, but comparisons across different gravitational potentials require care. When the mass in question becomes a black hole, these conceptual contours push into the uncanny. Imagine a beam of light sent from near the horizon outward. Each subsequent photon climbs out of a deeper gravitational well and arrives at increasing delay and with reduced energy. The pulses stretch and redden until the incoming stream becomes an attenuated hiss. To a distant listener, the object near the horizon appears to slow, its final moments frozen indefinitely on the brink of disappearance. The collapse is forever incomplete in coordinate time. Yet for the local, there is a complementary phenomenon tied to motion. Velocity can also dilate time. Special relativity teaches that as a system moves faster, closer to the speed of light, its internal processes decelerate compared to a stationary frame. This is the classic twin paradox. One twin makes a high-speed journey and returns younger than the twin who remained at home. In a gravitational field, these effects mingle. A spacecraft moving rapidly close to a massive object experiences both the time warping of velocity and the gravitational slowdown. The equivalence principle. The statement that together, these features suggest morally rich thought experiments about civilizations, archives, and the ethics of waiting. Consider a hypothetical population that chooses to dwell deep within a gravity, well to, in effect, buy more time relative to an outside universe. For them, subjective minutes persist while centuries slip by beyond the horizon. The practical consequence is an unsettling mismatch between local continuity and cosmic discontinuity. A culture that moves its cultural clocks into deep potential wells might preserve a way of thinking, a technological sequence, or a memory amid a universe that ages faster out. There are more concrete observational signatures that reveal time dilation at play. Astronomers routinely infer relativistic time, slowing around compact objects from the broadening and skewing of spectral lines. When ions near the innermost stable orbits of a black hole emit X-rays, those photons come to observers smeared and redshifted, a fingerprint of extreme gravity. Rapid variability, flickers in brightness that would be expected to occur on millisecond scales near a small black hole, are observed with different cadence depending on mass. Supermassive black holes, by virtue of their size, stretch these temporal signatures to. If the listener leans further into speculation, another interesting twist emerges. For an object falling into a black hole, the outside universe appears to accelerate rather than slow. Photons from distant galaxies are increasingly blue-shifted, packing more and more of the external cosmos into a shrinking proper time interval. In some coordinate descriptions, the infaller could witness, in principle, the entire future history of the external universe compressed into the last ticks before the singularity is reached. Whether quantum effects, tidal destruction, or a breakdown of classical description prevents any literal the phenomenology of this temporal asymmetry yields practical thought experiments. Suppose a probe, engineered with perfect clocks and robust transmitters, were positioned just outside an event horizon, sending data outward. From the probe's own sensors, systems would progress. From Earth, the probe's transmissions would grow fainter and more sparse, each packet carrying a longer imprint of the originator's heartbeat. Retrieval, even if technologically feasible, would confront a mess of signal stretching and information dilution. If the probe crossed the horizon, its last signals would undergo extreme redshift and delay, appearing to freeze on the threshold. That compression speaks to deeper anxieties about memory and oblivion. Black holes are, in many ways, the universe's archivists and erasers. Their gravitational pull archives matter into a region from which no conventional retrieval is possible. Hawking radiation and the debates about information loss suggest that even the record of what fell may be transmuted into a diffuse, nearly inscrutable form across cosmological timescales. Time dilation exacerbates the sense that records are not simply lost in space, but stretched in time until they no longer belong to the rhythms of their originators. Even on human scales, timing mismatches foster disorientation. An astronaut in low Earth orbit experiences a minute discrepancy over months. Astronauts on more ambitious missions, if ever they become reality, would confront more pronounced asynchronies. The conceptual challenge is not purely technical. It asks how a species constructs shared narratives across frames that age at different rates. How do cultures remain intelligible to one another when the basic unit of social life, the second, the day, the generation, becomes relative? These questions are not idle. They press at the edges of what is. The documentary voice, reflective and patient, draws attention to a subtle irony. Gravitational time dilation both humbles and empowers. It humbles by showing humans how trivial their chronological footprints are on cosmic scales. It empowers by offering different strategies for enduring pockets of culture in a transitory cosmos. That paradox is embodied in the image of an archival vault built near a deep gravitational well. To place artifacts in such a vault is to slow their decay relative to some external frame, a way of storing culture not by temperature or isolation, but by shifting the river of time itself. Yet, ultimately, the narrative returns to the question of perspective. Time dilation teaches an austere lesson about the plurality of temporal experience. It strips the universe of a single, universal clock, replacing it with a tapestry of rates, each determined by the local geometry of space-time and the velocities involved. In that tapestry, simultaneity phrase, history becomes a mosaic of overlapping durations. For the human narrator, the effect is at once vertiginous and consoling. Vertigo, because the idea that two observers can disagree so profoundly about the passage of moments unsettles the intuitive continuity on. The listener is left with an image that is both scientific and emotive. Clocks, once thought to be uniform metronomes, are instead small boats bobbing on a river that bends and quickens with mass. Near a black hole, those boats ride close to an eddy so powerful that the outside world's sunrises accelerate or decelerate in ways that jostle expectation. To consider what their time would be, whether they are a probe, a culture, or the gas in an accretion disk, is to measure not simply a rate, but a relationship. It asks how histories compare and how memory is preserved across horizons. Time dilation is thus not a footnote in cosmology, but a narrative device for thinking about deep time itself, how the universe inventories its past, how it paces its futures, and how conscious beings might find strategies to endure in a cosmos whose clocks refuse uniformity. In the cinema of the mind, the scene plays out in slow motion and in bursts of feverish speed, depending on where one sets the camera. The truth is neither formally melancholic nor triumphantly bleak. It is a reminder that temporal experience is location dependent, and that the simple question, how fast do they age? 3. Black holes and the event horizon. What does it mean to stand before a boundary that insists on finality? The question is not about crossing a physical threshold like a doorway in a house. It is about the universe marking an edge in the ledger of cause and effect and signing it with gravity. The event horizon is that edge. It is a mathematical curtain drawn round a region of space-time where the escape velocity exceeds light speed. In the language of geometry, it is the last surface from which light can still beat a path outward. Beyond it, every future is inward. To speak of the event horizon is to speak in two tenses at once. There is the external tense, in which observers trace orbits and signal delays and see matter collapse into a dim, stretched smear. And there is the internal tense, which belongs to local experience, where clocks tick on, sensations register, and the ordinary verbs of physics still apply, at least until classical equations cough and admit their own failure. The horizon itself has a stark, almost bureaucratic quality. It is a bookkeeping line in the metric that redraws the map of possibility. Cross it, and the causal diagram changes its topology. No future point inside the horizon can connect. The experience of approaching that clause depends on scale. For a small black hole, one, perhaps tens of times the mass of the Sun, tidal forces near the horizon are savage. The curvature gradient is steep across a body. The part of an object closer to the black hole is pulled more fiercely than the far side. The evocative metaphor, spaghettification, does not merely entertain, it describes the progressive elongation, the shearing of matter into a filament. The frames of classical intuition fail here because continuity itself frays, molecular bonds are broken, atoms separate, and the notion, by contrast, near a supermassive black hole, those millions or billions of solar masses that lurk at the centers of galaxies, an observer could, in theory, pass the event horizon with fewer immediate tidal indignities. The horizon there is so vast that the curvature felt at the radius might be mild. A body could remain structurally intact for many seconds, minutes, or longer of its own proper time before tidal forces finally accumulate. This split in possible local narratives is one of the universe's disquieting gifts. From one perspective, the horizon's power is not only mechanical, it is epistemic. Once something crosses, for practical purposes, the outside world loses access to its internal degrees of freedom. Quantum field theory and thermodynamics complicate that simple statement. Hawking radiation, entanglement, and holographic conjectures suggest that information might be encoded in subtle fluxes. But the point remains, the event horizon is a causal severance. No classical signal can return to the outside, no image can come back intact. The universe draws a line beyond which conventional retrievability. That line has a haunting temporal consequence. Gravity is geometry. Time slows in deep wells. A familiar turn of phrase in speculative narrations helps. An hour near the edge of a massive black hole can count for years or centuries far away. Imagine the arithmetic: a probe or a culture dwelling at a radius where time dilation is extreme could watch their seconds pass while entire civilizations elsewhere race through decades beyond their horizon. For practical values, the factor is controlled by the depth of the gravitational potential. The closer to the radius, defined by the Schwarzschild radius, the larger the dilation. That consequence generates paradoxes that have kept theorists in extended, unresolvable conversations. For the external observer, matter appears to slow as it approaches the horizon. Light gets redshifted, signals arrive later and later, and the infaller's last seconds smear into an asymptotic pale. The outside world watches a performance in which motion is arrested, as if the universe defers the final act indefinitely. Locally, however, the act completes. A finite proper time elapses and an unhappy end is reached. That split reality is not a failure of physics, but a testimony to the relativity. There is a more intimate way to frame the horizon's cruelty. Consider information, the detailed microstate of a system, positions, spins, correlations, the unique fingerprints of complexity. Classical determinism would like those details to remain reconstructible. Given enough time and the right equations, one ought to be able to rewind and reapply the laws to recover past configurations. Black holes appear to break that rule. If everything that fell inside were truly inaccessible forever, if evaporation left only a thermal, featureless residue, then information would have dissipated from the universe in a way at odds. Over decades, proposals accumulated. Some argued that the horizon is a kind of holographic ledger, encoding infallen information across its two-dimensional surface. Others suggested that Hawking radiation itself carries the correlations needed to restore unitarity, though in a form spread thin across vast timescales. Still, others proposed radical rewrites of spacetime near and inside the horizon, firewalls, fuzzballs, and various non-local mechanisms that would fundamentally change the fate of infalling matter. Each idea speaks to the entropy of ignorance. The emotional register that the event horizon evokes is not trivial. There is terror, to be sure. The simple notion of being carried into a place from which no light returns is existentially frightening. But there is also a stubborn humility. Standing mentally before such a boundary, human beings feel both vanishingly small and peculiarly persistent. Small, because the timescales and masses involved put personal drama into sharp, fleeting relief. Persistent, because curiosity refuses cancellation. To call the horizon a door of no. 4. Thought experiments. If the event horizon is a boundary of possibility, then thought experiments are a way of walking along its edge, shining hypothetical lamps into corners where equations and intuition contest. These mental exercises are not idle. They are how physicists and philosophers probe the meaning of the horizon without relying on spacecraft that, today, cannot deliver a report from behind the line. The thought experiments that follow are conceptual vignettes, each a precise image designed to stress a different facet of the horizon's implications. Consider an archival strategy. A civilization faced with a long-term extinction risk might be tempted to bury its cultural memory not under rock or ice, but deeper near a gravitational well where their metabolic time is slowed relative to the cosmos. The vault so conceived would be an experiment in temporal preservation. To place artifacts in a region of high time dilation buys subjective longevity. A composer's symphonies, a lexicon of languages, or a seed bank might experience the subjective preservation of centuries while the outside ages by millennia. Yet this strategy carries a paradox. Time dilation isolates in causal terms. Now imagine an experiment in observation. A probe is placed on a precarious orbit just above the event horizon, its instruments tuned to measure the grammar of gravitational redshift. It sends regular bursts of photons outward, time-stamped blips that are, in principle, readable by a distant listener. As the probe descends, each subsequent burst climbs out from a deeper potential, and the listener sees the sequence stretch. An hour of the probe's clock becomes years at the receiver. That data flow, once practical for coordination, becomes historicized in slow motion. The outside audience must develop in. Another thought experiment probes the information issue. Suppose, in a purely hypothetical construction, that a black hole could be manipulated to carry a coded signal on its horizon, a pattern in its quantum hair, if such exists. A civilization might attempt to write a message into the correlations on the horizon, trusting that Hawking radiation or holographic mappings would broadcast that message back across cosmological epochs. The experiment is more ethical than practical. It asks whether the fabric of space-time allows for durable messages in the face of entropy, and whether the universe's channels for information can be harnessed for cultural expression. A fourth vignette explores the notion of witnessing. In classical descriptions, an infaller might, in principle, see the outside universe accelerate, light from distant eras blue shifted into a furious cascade, packing more of external history into the last instance. Could any meaningful observation of the universe's future be made in this way? The thought experiment's answer is ambivalent. Quantum effects, tidal disintegration, and the breakdown of classical spacetime likely intervene, preventing a literal viewing of infinite futures. But the image remains instructive. Deep gravity. Finally, there is the civic thought experiment. How should a species organize its social life if some of its members choose to live in radically different temporal frames? If a subset opts for near-horizon living as a way to stretch subjective time, institutions will be strained. Contracts, pensions, cultural transmission all presuppose common temporal metrics. A society split across gravitational wells would need new norms for trust, new rituals for remembering, and new architectures for decision-making. This experiment is less about physics and more about anthropology. Each of these thought experiments is an exercise in perspective-taking. They force an admission that temporal experience is not an absolute commodity, but a relational one. They also highlight a moral question that shadows many speculative documentaries. Given finite attention, when should a civilization invest in slowing down its own time versus engaging with a faster external agora? The choice is not merely technological, it is ethical. It defines what a culture values: continuity of self, legacy to others, or participation in a shared narrative that moves at the cosmic pace. Taken together, sections 3 and 4 sketch an anatomy of boundaries and responses. The event horizon is an uncompromising geometric fact. It is the universe's grammar for saying that some causal relationships are closed. Yet human imagination is not content simply to observe that grammar. Thought experiments are instruments for translation. They allow a species to rehearse strategies, to imagine vaults and probes and messages, to confront the eventuality of erasure and to test whether erasure is absolute. The emotional note that carries through both is subtle and persistent. There is grief baked into the knowledge that some things, indeed, are swallowed and cannot be retrieved in ordinary ways. There is also curiosity, an almost obstinate optimism, that some remnant, encoded, reconstituted, or merely remembered, can persist. Most of all, there is humility. The event horizon refuses to be made trivial. It compresses timescales, severs causal chains, and insists that any claim about universality be qualified by frame. In that so the narrative closes this segment, not with a finality, but with an invitation. The event horizon is both a veto and a teacher. It says that, yes, some crossings preclude return, but it also exposes the seams of theory and the possibilities for new understanding. It asks listeners to think in larger temporal scales, to imagine archival strategies that are not only physical but ethical, and to accept that some answers may emerge only by stretching the human capacity for patience. In the shadow of such a boundary, what does it mean for a lifetime to arrive out of sync with its mirror image? That question is the hinge of the experiment, a deliberately stark staging of relativity's most intimate consequence. Time is not the same everywhere, and when one sends two otherwise identical lives down different gravitational tracks, the ledger of experience rewrites itself. The experimental setup is simple in description and bristling with implication in effect. Two twin human specimens, indistinguishable in biology and biography, volunteer as living clocks. One remains in a distant, sheltered orbit, a baseline against which the experiment can be read. The other pilots a vessel to the edge of a massive gravitational well, not across the event horizon, not into irrevocable darkness, but close enough that space-time itself conspires to slow the flow of subjective hours. The mission is engineered so that the near-horizon craft approaches, orbits briefly, then turns away and returns. Seen from the outside, the paradox is a tidy expression of well-understood physics. Clocks closer to a strong gravitational potential tick more slowly relative to clocks far away. Seen from within, the paradox becomes a moral and psychological problem. An experiment in how human relationships are rearranged when time ceases to be common currency. To make this tangible, the narrator leans on an image rather than an equation. Imagine two metronomes placed on different portions of a warped floor. One sits on a platform that, unbeknownst to its owner, descends imperceptibly into a valley of gravity. Its tick becomes slow, precise, resolute. The other metronome keeps its habitual tempo, its ticks piling up into years. Both metronomes mark life. Both are correct in their own frames. What changes is the map that relates those ticks. Before the mission, there is a long period of anticipation that reads like a small civic ritual, briefings, calibration of clocks, a last meal in the sterile dining of mission control. The documentary voice describes these moments with patient detail. The soft clack of a teacup against a saucer, the barely audible exchange of procedural checklists, the way an astronaut's hand lingers over a photograph taped into a flight manual. Speakers in the control room talk in clipped cadences about delta V and burn sequences. They speak with the calm of people trained to translate exceptions into steps. The human stakes undergird every Communications during the approach are a study in perspective. From mission control and the distant twins' perspective, radio pings stretch. Packet after packet arrives with widening gaps between timestamps. The data feed is the technical equivalent of a film being slowed. Heartbeat telemetry, reaction wheel stabilization, the cadence of breath, all of it decelerating in an exact, predictable way. If one watches the external feed as if watching a clock on the wall, the near-horizon astronaut appears to move in molasses. Instrument oscillations elongate, speech becomes an expanding series of syllables, and yet the narrative does not confine itself to the view from afar. The account provides texture to the interior experience. Inside the ship, time registers in the ordinary way. A task that takes an hour inside the cockpit is an hour to the pilot's bones. The pilot feels the warmth of a cup of something that can be called coffee. The pilot notices a small nick on the glove and files the notation for later. There is, in other words, a continuity of local life that belies the distortion visible from Earth. This is the important and disquieting juxtaposition. What looks like an eternal slow motion, the turning point of the experiment, the maneuver that takes the craft away from the gravitational lip and back toward the reunion, contains the conceptual knot that produces the social paradox. To execute the turnaround requires energy, a burn that changes the craft's trajectory and establishes an outward velocity sufficient to escape the deep potential. During and after that burn, the kinematic and gravitational contributions to time dilation change. Forces that were previously experienced as steady may spike, as the equivalence principle recasts acceleration as gravity in the local frame. For the pilot, the reverse thrust is an ordinary. When the two meet again, the reunion is not a cinematic embrace, but a complicated social procedure, medical checks, synchronization of lobes, and inventory of memories. The objective measurements are stark. Tight atomic clocks, the most impartial witnesses available, disagree about how much proper time each twin accumulated. The distant twins' watch has kept, say, 30 more years than the near-horizon twins. Biologically, The returning twins' telomeres, their skin elasticity, their vertebral compression, all match a body younger than that of their sibling. For the world that watches, the documentary voice leans into the human contradictions with compassion. There is the simple, visible strangeness of two people who shared a childhood and identical genetics being separated not only by space, but by a gulf of experience measured in decades. One remembers the deaths of friends, the slow fade of certain cultural habits, the brittle jokes about fashion. The other remembers none of those events. The older twin has a life's accumulation of griefs and bureaucratic particulars. The younger does not. In conversation, the rhythm is awkward, pauses to explain lost years, repeated descriptions of events. What follows, and what the documentary dwells upon, are the subtler injuries. Jealousy and guilt exist in a tangle. The older sibling may resent the younger's preserved youth, a petty, very human wound that sits uneasily alongside scientific pride. The returning twin may feel a strange survivor's guilt, not for the avoidance of death precisely, but for the sheltering of time itself. These emotions are not theatrical, they are the slow, corroding ways that people reorient themselves after a new physical fact becomes social reality. Transcripts and testimony, presented by the narrator as if reviewed from a careful archive, bring the listener closer without collapsing into melodrama. Mission debriefings are quoted in the dry language of procedures. Subject reports stable vital signs, subjective perception normal. Family interviews are softer, elliptical. They looked like themselves, but not, and we could not help asking which of us we were supposed to grieve. Small acts signal deeper adjustments. An elder child whose sibling returned younger asks, in a taped moment of private conversation, "What do I call you now?" The documentary voice does not. There are jurisprudential problems too, that the film-like narration examines with curiosity. Age determines rights and obligations in most societies. Voting eligibility, retirement, contractual liabilities. If two people born minutes apart return from a mission with decades of difference stamped into their physiology and papers, which temporal standard governs? Legislatures are suddenly called upon to define age in a relativistic age. Legal scholars and ethicists appear in the narrative, described in broad strokes, working through analogies. Is age a personal property tied to subjective experience, or a public metric that society must maintain? On the scientific side, the experiment is a triumph and a provocation. Scientists delight in the clarity of the data. Atomic clocks confirm the predicted dilation factors, jitter and noise are accounted for. Nothing violates the equations. Yet new puzzles emerge. How does memory itself fare under differential temporal exposure? Could cognitive processes be susceptible to nonlinearity when their biochemical substrates experience varying cumulative time? Neurologists caution that memory consolidation depends on a sequence of biochemical events whose timing may be desynchronized. The narrative does not shy away from a broader cultural blush. Artists, poets, and commentators seize upon the twins' story because it condenses larger anxieties about continuity in an accelerating world. Some treat the younger returnee as a symbol of renewal, proof that the human experience can be quarantined from the entropy of passing time. Others see in the older twin a cautionary tale about the inescapable cost of lived history. Museums and archives, themselves guardians against the forgetting that gravity can exaggerate, stage exhibitions that pair artifacts with the twins' testimony. There is, too, a political dimension that the documentary voice explores with care. Access to near-horizon missions is not distributed evenly in this speculative world. If the technique of buying subjective time becomes an option for the wealthy or the powerful, inequalities in lifespan and generational continuity would be magnified in new ways. Debates ripple across the public sphere. Should access to temporal sheltering be regulated? Would societies become stratified into those who can literally extend their personal present and those who remain on ordinary calendars? The twin experiment, in the larger imaginal sense, becomes a probe into justice when time. Throughout the segment, the narrator returns to a single philosophical observation. The paradox is not that physics fails, but that human institutions are brittle in the face of relativistic truths. the mathematics remain tidy, the unsettling fact is that persons, communities, and laws are constructed around an assumption of shared time. When that assumption fractures, the consequences spill into markets, into mourning, into marriage, into what counts as a career. Towards the end, the documentary considers the cognitive strategies people adopt to live with the discrepancy. Rituals arise to bridge the gap, reunions designed like rites of passage, legal documents termed tempo contracts that specify which temporal frame governs certain obligations, social practices that explicitly acknowledge differential aging. Some communities develop shared narrative practices, regular retellings of events that allow memory to be re-anchored for those who were absent in certain decades. Others retreat into technocratic fixes, synchronized logbooks. The tone throughout is contemplative rather than alarmist. The twin experiment is used by the narrator as a lens. It magnifies questions already latent in our treatment of time as social capital. It asks whether survivorship, memory, and identity are anchored in biology or in the weave of the community's ongoing story. The final image is deliberately ambiguous and inward. Two siblings, two biographies out of phase, each with legitimate claims upon the other's life. One has more chronological years to account for loss and duty. The other has earned a kind of actuarial youth that complicates. In closing the segment, the narrator offers a measured invitation rather than a tidy lesson. The observation paradox, the astonishing fact that one can return younger after skimming a gravitational lip, is both a vindication of scientific insight and a prod to moral imagination. It shows how physical truths, once translated into social fact, bend the grammar of everyday life. The twins are, in the film's careful rhetoric, not characters in a melodrama, but exemplars of a larger dilemma. When the river of time can be rerouted, who gets to choose the course, and how do we repair the... To stand before that question is to feel both delighted and disquieted. The delight is the deep satisfaction of a theory confirmed in living bodies. The disquiet is the realization that some of the most profound questions about the universe do not end with equations. They continue in kitchens, courtrooms, hospital wards, and at kitchen tables where people ask, in simple voices, how to call someone whose years do not align with their own. The documentary voice lingers there, inviting the listener to imagine the awkwardness, the tenderness, and the needed courage of answering that question together. What if the cosmos contained a place that behaved like a sentence cut off in mid-thought? A place whose grammar rearranged verbs and nouns so that what one could say about motion, cause, and consequence changed depending on the seat from which one told the tale? That is the unsettling image that opens the next question. When an observer crosses the event horizon, what actually happens beyond the elegant bookkeeping of coordinates and asymptotic approximations? The image is simple and precise. From a distant vantage, the approach appears frozen on the rim, a slow, reddened tableau. From the infaller's pocket of experience, time goes on with its usual rhythm. Seen from far away, the horizon behaves like a mirror of time. Photons, the messengers of causal information, struggle to climb out of the well. Each one leaves with less energy and longer wavelength, each emission delayed relative to the last, and the sum of many such emissions becomes an image of arrested motion. The approaching object stretched into an everlasting curtain. To a far observer, then, the horizon is a kind of frozen frontier, an asymptote on the temporal graph where the final act seems always a moment away. But the mathematics of proper time, the time measured along the infaller's own world line, offers this dichotomy, infinite delay versus finite crossing, is not only a technical curiosity, it has consequences for how the universe is narrated, archived, and remembered. If the outside universe can only ever see an approach that never consummates, then the last visible traces of an infaller are stretched into a slow-motion relic, an attenuated record that decays by redshift. For the infaller, however, the narrative continues. Instruments tick, sensations register, and a future awaits that is causally severed from the outside. That future may be brief, violent, puzzling, To appreciate what happens beyond the horizon requires attention to scale. In a small black hole, tens of solar masses, tidal forces near the horizon are dramatic. The curvature of space-time changes rapidly over short distances. The head experiences a stronger pull than the feet. Molecules are stretched, and the colloquial spaghettification is more than metaphor. Structural integrity is compromised before long. The body and instruments are drawn into a filamentary stream of matter and energy. Under those conditions, the classical singularity. In contrast, supermassive black holes, those at galactic centers with millions to billions of solar masses, present a gentler facade at the horizon. There, the curvature scales are much larger. An observer could, in principle, cross the event horizon without immediate tidal destruction. The crossing would feel ordinary for many seconds or minutes of proper time. That apparent benignity is a crucial distinction because it means the event horizon is not uniformly violent. Its nature depends on the mass that defines it. In the supermassive case, the dramatic consequences shift inward, deferred to deep proper. And it is there, at the intersection of classical geometry and quantum microstructure, that the heart of the question throbs. The classical prediction of a singularity is a signal, not merely an endpoint, but a proclamation of theory breakdown. Singularities are where curvature invariants blow up and the differential equations lose predictive power. They are not necessarily real in the sense that nature must realize them. Rather, they ask for a better theory. Quantum gravity, whatever its final form, must reconcile the smooth manifold of One speculative resolution is the smoothing or resolution of the singularity into a Planck-scale region where space-time loses its continuum description. In such scenarios, the infaller does not meet an infinite curvature point, but rather encounters a region where unpredictable quantum geometrical dynamics dominate. Some proposals suggest that this phase might spawn a bounce, a transition into a new expanding region of space-time, perhaps a nascent baby universe branching off behind the horizon. The idea is arresting. The black hole becomes not a mere sink, but a seed where matter and information. Another influential line of thought reframes the horizon in terms of information and holography. According to the holographic principle, the information content of a volume of space can be encoded on its boundary surface with a density proportional to area rather than volume. Applied to black holes, this idea suggests that the microstates that account for a black hole's entropy reside on, or are at least reflected by, the horizon itself. Bekenstein and Hawking's discovery that black hole entropy scales with area supplies the thermodynamic skeleton for that conjecture. If the horizon is indeed a kind of holographic screen, then over the past decades, theoretical gymnastics have proposed mechanisms for how information might escape. Hawking radiation, once thought purely thermal and featureless, could carry subtle correlations that encode in fallen information. In that account, the outgoing quanta are not independent, but entangled in such a way that, over the enormous timescale of evaporation, the state of the original system is, in principle, reconstructible from the pattern of radiation. Implementing this idea requires delicate bookkeeping and a quantum mechanical account of correlations that challenges semi-classical approximations. The AMPS firewall argument raised another illusion. String theory and related frameworks have offered alternate pictures. The fuzzball proposal conceives of black holes not as simple horizons surrounding nothingness, but as ensembles of horizon-sized stringy microstates that replace the would-be horizon with a complex, structure-filled region. In that picture, the infaller does not pass an empty geometric membrane, but encounters a hot, messy structure, reflective of the microstate composition. Here too, the classical intuition of benign crossing fails, but the failure has a different flavor. It is not a particularly evocative bridge between space-time geometry and quantum entanglement was offered by the ER-EPR conjecture. The suggestion that entangled particle pairs, EPR pairs, are connected by non-traversable wormholes. Einstein, Rosen bridges, ER. Extrapolated to black holes, this idea hints that entanglement and geometry might be dual aspects of the same underlying structure, and that information escaping via Hawking radiation might correspond to emergent geometric connections. While deeply speculative, such proposals shift the problem from a localized paradox to a question about the fundamental dictionary between entanglement. All of these theoretical attempts bear on the same experiential puzzle: what does the falling observer see and feel? In the classical supermassive case, the crossing itself could be uneventful, even as the outside universe seems to accelerate into a bright, blue-shifted furnace, photons from the outside boosted in energy as they fall into the deepening potential and pile up behind the infaller. In small black holes, by contrast, tidal disruption dominates, structural disintegration occurs quickly, and the experiential content collapses into physical destruction. In quantum-centered scenarios, firewalls and fuzzballs, the very notion of a smooth crossing is called into question. There is also the thermodynamic dimension to consider. Black hole mechanics mirror the laws of thermodynamics. Surface gravity corresponds to temperature, area to entropy, and changes in mass to energy fluxes. Hawking's realization that black holes radiate thermally endows them with a temperature inversely proportional to mass and a finite entropy, proportional to horizon area. These attributes invite an interpretation of horizons as thermodynamic ensembles, not mere geometric surfaces. Entropy, in this telling, measures the hidden microstates and hence the repository of ignorance. Beyond the technical debates, there is an existential and philosophical register that the crossing touches. The event horizon is an ultimate decider about the publicness of events. Once a world line dips irreversibly across it, the external universe can no longer witness the culminating chapters. That fact reframes questions about accountability, record, and testimony on cosmological scales. If a civilization were to send probes or transmitters across the horizon, those final communications would be subject to extreme redshift and delay, converted into the faintest echoes before vanishing. Yet the horizon also opens an imaginative space for humility and reinvention. The multiplicity of possible fates beyond it, singularity, bounce, baby universe, fuzzball, firewall, or some as yet unknown quantum gravitational tapestry, is testimony to the limits of current understanding and to the productive tension that arises when theory and principle collide. Far from signaling defeat, that tension invites new conceptual languages, operators that encode horizon microstates, geometrical entropies that bridge fields and spacetime, and experimental proxies. Practically, the question of what happens beyond the horizon remains stubbornly disconnected from empirical closure. No signal can return from within a classical horizon, and therefore the enterprise of understanding the interior becomes an exercise in inference, consistency, and theoretical economy. The scientific community responds with humility and ingenuity. By testing the external predictions that correlate with different interior models, by studying black hole analogues in laboratories, by seeking patterns in gravitational wave signatures and high-energy emissions that speak to near-horizon structure. In the narrational mode of a speculative documentary, the crossing of the horizon is thus both question and teacher. It dramatizes how deeply physical realities are married to epistemic constraints. The universe allows certain regions to be forever private, and those private regions in turn shape the public story by their very absence. The horizon challenges the narrators of cosmic history, physicists, philosophers, and curious minds alike, to rethink what counts as knowable and how to craft stories that remain faithful. Finally, and perhaps most simply, the horizon returns the speaker to an attitude of patient wonder. Whether the infaller meets a ruinous singularity, a gentling quantum transition, or a fractalized microstate, the fact that such possibilities exist demonstrates the richness of the cosmos's available scripts. The event horizon is no longer merely a limit of classical motion. It becomes a crucible for the dialogue between geometry and information, between the public and the private, between the measured and the immeasurable. To stand before that door is to accept that some answers will arrive only as the mathematics and the imagination co-evolve, as instruments improve. What if the interior of a black hole was not merely a point of finality, but a locus where several stories of the universe braided together, each story telling a different fate for whatever crossed the threshold? That image, a plurality of possible endings, is the hinge of this section. It asks not simply whether matter is shredded or reborn, but what kinds of metaphysical continuity a cosmos can permit when causality is bent to its limits. The question is at once technical and existential, crushed into strings, dissolved into quantum foam. On the physically conservative page of the ledger sits spaghettification, the blunt geometric violence that classical gravity warns will befall many infallers. In intuitive terms, a gravitational gradient stretches and shears. The part of an extended object nearer the singularity is pulled more strongly than the part farther away. At human scales, this becomes an image of elongation, a body drawn into an ever narrower filament. But the drama does not end at a metaphor. At progressively smaller scales, the elongation translates into real structural failure. Molecular bonds succumb, chemical order dissolves, and spaghettification. Spaghettification is a consequence of tidal forces in a strong curvature regime. These forces increase as 1 Rho 3 in Newtonian approximation for many mass distributions near compact objects. Relativistic corrections intensify the effect. In small black holes, those on the order of stellar masses, the radius at which tidal forces become lethal sits well outside the event horizon. In such cases, physical disintegration arrives before the horizon, meaning the notion of a smooth crossing for any macroscopic body is a fiction. The falling matter becomes a thin, radiant filament that adds its energy to the surrounding plasma and, ultimately, yet the universe permits gentler crossings in other corners of parameter space. Supermassive black holes, those that sit in galactic cores and weigh millions or billions of suns, have event horizons so vast that the curvature at the crossing radius can be arbitrarily small. An object falling into such a behemoth can pass the horizon with little immediate tidal stress, experiencing an interval of proper time that feels startlingly ordinary. This apparent benignity is philosophically significant. The horizon is not a uniform monster, but a geometric feature. And here, the narrative branches into hypotheses that are less quotidian and more speculative. One family of ideas suggests that the classical singularity is not a true terminus, but a clue pointing to a deeper quantum regime. In some quantum gravity models, the core of a black hole becomes a Planck-scale region where space-time is no longer continuous, but discrete, foamy, or polymeric. There, the relentless compression that classical relativity predicts is arrested by quantum repulsion. Instead of an infinity, there might exist a maximal density and a subsequent bounce. If that bounce has macroscopic consequences, it could seed it. This baby universe picture is not merely metaphysical whimsy. It appears in several theoretical exercises, loop quantum gravity, in which a collapsing core rebounds once Planck's scale physics becomes significant. Cosmological natural selection scenarios that propose black holes as progenitors of new universes with slightly varied physical constants, and semi-classical sketches where tunneling phenomena connect collapsing spacetimes to expanding ones. If true, such schemes reframe black holes from cosmic tombs into reproductive organs of a multiverse, repository are rearranged into the soil of a nascent one. A different speculative avenue asks whether a black hole's interior could be a doorway, not merely to a child universe, but to a parallel or topologically different space-time within the same overall manifold. Earlier days of general relativity inspired fanciful images of Einstein, Rosen bridges, geometric connections that link two asymptotically flat regions. In their original classical form, these bridges pinch off too rapidly to serve as traversable thoroughfares. But when quantum fields are allowed to back-react or when exotic matter with negative energy density is posited, the mathematics admits solutions that are, at least in principle, true. A cousin to this thought is the ER-EPR conjecture, which offers a conceptual reconciliation between entanglement and geometry. This line of thought proposes that entangled pairs of quantum systems are connected by non-traversable wormholes at the fundamental level. If so, then black hole interiors and their Hawking radiation might be tied by a web of microscopic wormholes encoding entanglement correlations. The consequence is a radical reimagining. Geometry and information are dual languages describing the same thing. In such a view, going inside gains a metaphorical meaning. There are still more extreme suggestions, voices in the theoretical chorus that toy with audacious possibilities. Could an interior host a stable, traversable conduit to a parallel universe with different physical constants? Could the interior be a refuge rather than a grave, somewhere where causal constraints are loosened enough to permit forms of survival beyond classical recognition? These ideas, while thrilling to imagine, bump hard against a wall of conservatism rooted in observational inaccessibility and fundamental constraints like causality and energy conditions. The cosmic censorship conjecture, the expectation that nature hides, that veil is central to the modern information paradox. If classical horizons are impenetrable to retrieval, does that mean information is truly lost? Quantum mechanics insists that evolution should be unitary, information-preserving, so theorists have crafted elaborate reconciliations. One line insists that information is, somehow, encoded on the horizon surface itself, a holographic ledger storing microstates proportional to area rather than volume. Another contends that Hawking radiation, once considered thermal and featureless, must carry the imprint of what fell, but in correlated, exquisitely subtle. From the perspective of deep time and lost civilizations, the consequences are melancholic and oddly consoling by turns. If a culture's artifacts, language, genomes, structural complexes were swallowed intact by collapse and subjected to spaghettification, their macroscopic identity would be destroyed. Yet the microphysical information they embodied, under many quantum accounts, need not be forever annihilated. It may be scrambled into correlations on the horizon, smeared into the spectrum of Hawking radiations, or transplanted into a newborn spacetime where, hypothetically, those correlations could participate in new structures. The timescales in this temporal generosity opens ethical and cultural thought experiments. Would a civilization choose to send its records into a black hole as a form of deep time insurance, betting on unknown quantum archival pathways rather than on the frailties of physical repositories? If the black hole becomes a monument rather than an enemy, it alters how a species conceives legacy. Yet such an investment is speculative and costly. Access to near-horizon proximity is rare, and the causal isolation might render the gesture symbolic rather than practical. The image is powerful. However, a culture composed. Another axis of speculation concerns the phenomenology an informer might witness before any putative quantum transition. In classical supermassive scenarios, light from the external universe becomes increasingly blue-shifted as it falls inward, compressing cosmic history into a dazzling, high-energy burst stacked into the informer's last moments. Whether that represents any meaningful opportunity to see the future of the outside universe is doubtful. Tidal disruption and quantum indeterminacy almost certainly curtail any coherent observation. But the imagery serves an evocative purpose. There remains, finally, the philosophical register of the interior's mystery. Whether the fall ends in annihilation, rebirth, or secret preservation, the interior challenges the human impulse to render the cosmos legible. It insists upon humility. Horizons mark the limits of what public knowledge can ever assert. Yet the plurality of theoretical possibilities transforms that humility into a kind of creative patience. The absence of empirical closure compels an array of mathematical languages and metaphors, from holography and entanglement, geometry to quantum bounces and baby universes. For the species whose curiosity stares at such boundaries, the lesson is twofold. First, the universe is capacious enough to allow many fates for matter and information, and these fates are governed by principles that may be both local and global: tidal gradients and Planckian physics, entropy and entanglement. Second, the long-term ledger of existence might be written in alphabets not yet known. inscriptions that need patient mathematics and instruments to decode. To imagine a civilization swallowed by a black hole is, in one reading, to imagine a story that ends, in another, to imagine a transition into a different narrative mode. So the contemplation of what lies within invites neither certainty nor despair, but a renewed appetite for translation, to invent languages that can describe the quantum bookkeeping of horizons, to build telescopes and detectors that can read the near-horizon signatures left on light and gravity, and to practice a cultural patience that reckons with deep time. The image best left with the listener is not that of finality alone, but of plural possibility, a topology of endings that includes erasure, smearing, rebirth, and connection. The black hole's interior remains a contested and compelling frontier, a locus where physics. What, precisely, does it mean to return to a world that has grown into a stranger while one's own heart has kept its former rhythm? That question is the hinge of this section. A conceptual blade that slices through physics, memory, and social life. The image it invites is simple and terrifying, a person or a probe that lingers near a deep gravitational well, buys subjective hours or years, and then turns back to find the public clock rewound, accelerated, or otherwise irreconcilable with the life that waited. The cognitive and cultural aftershocks of such a return are not merely silent. The phenomenon begins with the arithmetic of relativity and ripples outward into memory. From the outside, the world ages according to one metric. Calendars mark births, deaths, revolutions, institutions, wax and wane. Near a heavy potential, subjective time bows inward. A decade lived close to an event horizon might correspond to centuries for those beyond it. For the returnee, the most intimate, immediate registers, pulse, taste, the weight of familiar objects, remain anchored to a life that feels contiguous. Yet the ledger of social life tells a different tale. Streets have been renamed, languages have drifted. To understand the depth of that dissonance, it helps to translate the physics into the everyday. Memory, both personal and institutional, depends on networks of references, photographs linked to faces, stories passed across kitchens, legal records referenced by courts. These meshes are durable only insofar as participants maintain the same temporal frame. When one node of the network undergoes a disproportionate slowdown, the ties fray. A photograph that once signified a shared event now corresponds to decades of absence. A social role, a job title, a parental duty may have been redistributed. The emotional texture of this drift is worth describing with care. It is less the melodrama of seeing a cityscape transformed. That image is vivid, but too external. And more the quieter disruptions, a voice on the other side of a video feed that uses slang born long after the returnee's subjective youth. A law that treats one as elder or ward contrary to one's felt age. A grave whose headstone lists familiar names that the returnee remembers as alive. Those little collisions accumulate into a particular grief, not only for the loss of people and places, but for the evaporated assumption of intelligibility. Institutional responses to this kind of temporal dislocation reveal how brittle social ordering can be. Legal systems have conventions about age, succession, and contract that presume a shared calendar. The returnee's biological markers, telomere length, bone density, hormonal profiles, may argue for one chronological status, while documentary records argue for another. Legislatures and courts may adapt with new categories. Relativistic returnee becomes a technical term in statute, accompanied by protocols for pension rights, inheritance, and citizenship. A different, quieter crisis unfolds in memory institutions. Museums, archives, libraries, the keepers of public memory, face an existential question when their timeframes are not shared. An archive that was once curated according to a cultural continuity may find that the meanings of its objects have mutated in unexpected ways. A seed bank or a corpus of literature that was intended to preserve a civilization's voice for future generations might be relocated into a temporal pocket where the very audience that could read it has thinned or transformed. Preservation, historically conceived as a technical problem of entropy in climate, the psychological strain of returning to an outpaced world also has a neurological component. Memory consolidation depends on sequences of biochemical events that are sensitive to rates and rhythms. Sleep cycles, hormonal fluctuations, and social reinforcement loops contribute to the way experiences become durable recollections. When an individual's subjective timeline diverges too dramatically from their social cohort, the intersubjective reinforcement that turns episodic memories into collective narratives becomes sparse. The returnee may remember events in crystal clarity, but find that besides individual psychology and institutional law, the return imposes a political economy. If strategies to slow subjective time, orbital shelters, near-horizon vaults, gravitationally shielded habitats become technically available, access to them could aggregate along pre-existing lines of privilege. The ethical hazard is stark. Time itself, the primary resource of life, might be hoarded by those with means. Inequalities would not be limited to wealth, but expanded into longevity of projects. Dynasties that invest subjectively in long-term planning could outlast political regimes, culture. Yet there is also a countervailing impulse toward generosity. Communities that anticipate such fractures might create narrative practices designed to bridge temporal gulfs. Ritualized retellings, continually updated oral histories, and technologically backed living archives. Media that update themselves with context and cross-references can partially restore intelligibility across frames. The idea is to make memory less brittle by ensuring that any returnee finds a living scaffolding rather than a fossil record. The social technology here is as important as all of these practical and human consequences lead naturally to a deeper overlapping worry, the fate of information itself. If individuals and institutions can be torn out of sync with their own histories, what does that say about the universe's capacity to preserve the raw facts, the detailed microstates of existence? This moves us to the next theme, the problem of lost information, the paradox that sits at the juncture of black holes and memory. One of the most persistent and unsettling riddles in theoretical physics is the fate of information that falls into horizons. That sentence, short and technically phrased, carries an enormous cultural weight. Information, in the quantum sense, is the complete specification of a system's state, the positions, momenta, spins, correlations. It is not a story in words alone, but the inventory that allows one, at least in principle, to reverse the evolution of a system. Classical determinism would prefer that such inventories persist in sub. Stephen Hawking's discovery that black holes radiate, an insight born at the crossroads of quantum field theory and gravity, introduced a new thermodynamic language. A black hole has a temperature, emits radiation, and slowly shrinks. If that radiation were perfectly thermal and featureless, it would carry no detailed imprint of what had fallen in. Over the enormous time it takes for a black hole to evaporate, its mass energy might be returned to the universe in a way that betrays nothing of its prior content. Information, as quantum mechanics insists, would be destroyed. This is not merely a technical. The paradox is not just academic. It touches the logic of cause and effect and the principle of unitarity that underpins quantum theory. The idea that pure states evolve into pure states and that information is preserved. If information can be annihilated, then the foundational symmetry of reversible evolution is broken. Philosophers, ever alert to consequences, have noted that such a breakdown would have cascading implications for predictability, for the very meaning of chance, and for the metaphysical comfort many derive from a law-governed cosmos. Several imaginative threads have been spun to reconcile these tensions. One strand reimagines the horizon as an information surface. Rather than a plane of oblivion, it is a ledger where data can be imprinted, smeared, and encoded. The holographic principle, the notion that the information content of a region scales with its boundary area rather than its volume, arises naturally here. If the horizon stores information in a way analogous to letters written on a page, then the evaporation process might, in principle, leak those letters back out in an exquisitely correlated pattern. The difficulty is technical. Another response highlights non-locality and entanglement. Hawking radiation is not produced in isolation, it is entangled with degrees of freedom that remain near the whole. Over time, the pattern of entanglement can become complex enough that the outgoing radiation inherits correlations that encode the past. Yet this route confronts the AMPS firewall argument and related challenges. To prevent cloning of information or violations of quantum monogamy, some cherished tenets of locality or the smoothness of spacetime might have to be sacrificed. The debate thus becomes a contest of principle. Other proposals are more radical in their ontology. Perhaps information is not lost from any global ledger, but transferred to a causally disconnected domain. A baby universe, a branch in a quantum multiverse, or a region where the bookkeeping continues under different rules. If so, then from the parent universe's standpoint, information is effectively lost, while from the larger megastructure it is conserved. That perspective reframes the paradox as a mismatch between local visibility and global accounting. But it offers less solace to any civilization that wishes its record. From the vantage point of cultures contemplating long-term legacy, the physics becomes a parable about preservation. Sending a record into a black hole is not an act of burial so much as a wager on metaphysical accounting. If one believes in practical recovery, the horizon as a recoverable archive, then the act is an investment in distant decipherment. If one accepts effective loss, then the act is symbolic, a ritual of faith that the cosmos will remember even when local audiences cannot. Whatever the technical resolution, the problem of lost information ties back to the central human anxiety of this segment, the fragility of continuity. Whether the issue is an individual returning to a world that has sprinted ahead, or the cosmological question of whether a black hole's appetite erases history, both concerns are about testimony and trust. To whom or what can a civilization entrust its story? To fragile stone and polymer? To durable quantum correlations smeared on a horizon? To an enterprise of ritualized retelling that the scientist's answer is stubbornly procedural, devise tests, search for delayed correlations in Hawking-like emissions, refine holographic models, probe gravitational waves for near-horizon deviations. The ethicist's answer is procedural too, but in human terms, build redundancy into memory, cultivate intergenerational narrative practices, distribute the stewardship of cultural heritage so that no single mode of preservation becomes the only hope. In the end, the collision between the returnee's dislocated life and the information paradox is instructive because it reveals the same pattern at different scales. Both are stories about the limits of retrieval, the personal archive of a life, and the cosmic archive written by physics. Both demand humility. The more one trusts in a single ledger, whether a family memory or a quantum state, the more vulnerable one becomes to the universe's patient erosions and to the social drift that relativity makes possible. The narrator's final invitation in this section is not to provide definitive answers. Physics does not yet permit those, but to reorient the listener's sense of what matters. If time can be stretched, delayed, and desynchronized, and if information can be smeared into forms that are unreadable on human timescales, then preservation is both a technical problem and a moral project. The technologies and theories that grapple with horizon physics are part of that project. So too are the cultural practices that allow memories to be translated across tempos, rituals, legal frameworks, archives designed not merely to keep. To return to a world that has run ahead is to discover that memory is not a private vault, but a shared conversation. to confront the possibility of information lost to horizons is to recognize that the universe's own bookkeeping will force human beings to be inventive about what they choose to preserve and how. The cosmos sets limits. Humanity, in its characteristic stubbornness, decides how to live within them. That decision, how to stitch continuity in a world where clocks do not agree and where horizons may obscure the past, is the ethical and intellectual labor that follows from the. What if the universe built not only jaws but also gears, vast spinning mechanisms whose motion rewrites the rules that govern energy, memory, and the fate of things? That image is the quiet shock that emerges when the conversation shifts from static, non-rotating black holes, the cosmic machines that spin. They are not merely heavier or grander, they are qualitatively different. Rotation drapes space-time with a new kind of drama, frame dragging, ergospheres, the possibility of energy extraction, and interior horizons that bend determinism itself. In the long, patient ledger of deep time, spinning black holes act like mills, but Stephen Hawking's revelation in the 1970s was a pivot. A black hole, once treated as an absolute absorber, was found to glow faintly when quantum fields were considered on a curved background. Vacuum fluctuations near the horizon produce particle-antiparticle pairs, and to a distant observer, the hole radiates thermally. The effect assigned a temperature to the horizon and an entropy proportional to its area. At first, Hawking's calculations seemed to doom information to a kind of cosmic evaporation. If the radiation were perfectly thermal, it would contain no imprint of the detailed microstates. A rotating black hole is not spherically symmetric, features an eccentric around, and Einstein's equations, discovered by Roy Kerr in 1963, revealed a structure with several concentric features, an outer event horizon, an inner Cauchy horizon, and between them a region where frame dragging is so violent that everything is compelled to co-rotate. The ergosphere is not merely a geometric curiosity, it is a working surface. Within it, rotational energy is extractable. The Penrose process, a thought experiment proposed in the late 1960s, shows that a particle sphere can split with one fragment forward. If a spinning hole can power jets and fling energy outward, what does that imply for the information problem? Two observations are immediate and unsettling. First, rotation increases the degrees of freedom of the black hole. Spin is an additional parameter in its macro state. The entropy associated with a Kerr black hole depends on its horizon area, and that area is affected by angular momentum. A spinning horizon has more complex structure. Second, the processes that mediate extraction of energy, Penrose-like interactions, superradiance scattering, magnetically driven. Superradiance, the wave analog of the Penrose process, is particularly telling. Low-frequency waves impinging upon a rotating hole can be amplified and reflected, extracting a bit of the black hole's rotational energy. The amplification depends on the wave's frequency and the hole's angular velocity. In effect, the space-time acts like a selective amplifier. The phenomenon has two deep consequences. On the astrophysical side, it provides routes for energy and angular momentum to leave the black hole's vicinity, contributing to spin-down and observable signatures. On the theoretical, Kurzschlussschwalst, black holes have a simple cause-child. Black holes have a simple causal structure, and event horizons, by contrast, possess inner horizons, where one may encounter an inner horizon where, like physically, the Kurzschluss in Gaussian gets down. In classical general relativity, crossing the event horizon of a Kerr black hole does not necessarily thrust a traveler immediately into a crushing singularity. One may encounter an inner horizon where small perturbations are amplified enormously. Physically, the Cauchy horizon is unstable. Ingoing and outgoing perturbations can blue shift exponentially. Modern attempts to reconcile unitarity with horizons have invented a variety of metaphors and mechanisms, and many of these take on new shades in the rotating case. The holographic principle, given concrete form in the AD-CCFT correspondence, suggests that the degrees of freedom in a volume of space are encoded on a lower dimensional boundary. If a black hole's microstates are indeed captured by a boundary theory, then rotation should be mirrored by corresponding structures in that dual description, spins, currents, and angular momenta that the boundary theory can read and, in principle, decode. In more pedestrian quantum, the story of soft hair broadens this possibility. In the mid-210s, Hawking, Perry, and Strominger proposed that black holes carry an infinite set of soft charges associated with large-gauge transformations, degrees of freedom dubbed soft hair, that could store information about what fell in. Although the proposal remains contentious and incomplete, it opened a conceptual door. Perhaps horizons are not featureless, perhaps their surfaces register the passing of matter in subtle, symmetry-linked imprints. For rotating black holes where angular structure and frame dragging break spherical, yet caution is necessary. The firewall argument, the claim that, to preserve unitarity while keeping quantum monogamy intact, an infaller must encounter high-energy quanta at the horizon, remains a blistering challenge to the hope of benign horizons. Rotation neither dissolves nor conclusively resolves that debate. If anything, it thickens the stakes. A rotating horizon that seethes with quantum structure would change the infaller's local experience and the outside observer's expectations simultaneously. The spin alters the geometry and the kinematics of entanglement in ways that are still being sorted mathematically. Empirically, rotation leaves fingerprints that observers can read. The spectacular jets from quasars, the relativistic broadening of iron K alpha lines in X-ray spectra, the time variability of accretion flows, and the polarization of emitted light all register rotational dynamics. Gravitational wave astronomy has added another instrument, the in-spiral and merger waveforms measured by LIGO and Virgo. And final remnant, spin affects the phasing of gravitational waves and the ring-down modes after merger. In those signatures, the universe offers a laboratory. By measuring spin, speculation, when carefully framed, can be a necessary tool for thinking across timescales that far exceed human patience. If a civilization were to attempt to use a Kerr hole as an energy reservoir, rotation would be an ally and a complication. The ergosphere provides a surface for interactions where matter can exchange energy and angular momentum with the whole without irreversibly disappearing behind the event horizon. A culture might, in principle, use the rotational degrees of freedom as a medium for encoding signals in the outgoing flux or to power devices that exploit frame dragging. Yet the same features that permit extraction, that patience, is the cruel currency of deep time. Even if rotation enhances the channels by which information can be outwardly impressed, the timescales for meaningful recovery may dwarf the lifespans of any conceivable society. Hawking radiation is feeble and slow, and while rotation can increase the richness of emitted spectra, it cannot make evaporation brief for massive holes. A supermassive Kerr black hole may spin down over eons, feed jets for millions of years, and evaporate over periods that render human comprehension microscopic. The promise that rotation, beyond practicalities, the existence of spinning black holes, shapes a philosophical mood. They amplify the sense that the cosmos is not indifferent, machinery, but a complex workshop. Gravity's ability to couple to motion produces arenas where determinism loosens at the edges, where information must be accounted for in more intricate ledgers, and where the tools for reading those ledgers require forms of mathematics and instruments that human cultures are only beginning to imagine. The Kerr solution is elegantly analytic on paper, but ferociously recalcitrant in truth, in a horizon's mass inflation quantum. In the end, the rotating black hole is both apparatus and paradox. It is a machine that can be tapped for energy and a boundary that complicates the fate of information. Hawking's insight that radiation could, in principle, carry information outward became more promising when one contemplates rotation, because the rotational dynamics introduce extra degrees of freedom and channels for correlation. But the new channels are woven with instability, and the physics inside remains uncertain. The spinning hole therefore resists both easy hope and simple despair. It invites a sober humility to believe that the universe is cunning enough for listeners who feel the smallness of human life against such cosmic machinery The image is paradoxically consoling. Machines imply craftsmanship, and the universe's craftsmanship occurs according to principles that can be learned. Rotating black holes turn. Their motion etches into space and time patterns that, if read carefully, tell stories of energy, memory, and transformation. The task then becomes not to wrest final pronouncements from horizons in a single generation, but to develop patient languages and instruments that can translate the whispers that rotation scatters across deep time. What if rotation were the universe's secret clockmaker? A quiet, inexorable twist added to gravity's script that could, under certain conditions, braid space and time into loops. That image is the lodestone of this section, not mere motion, but motion that rearranges the very grammar of causality. In the language of general relativity, the Kerr black hole is a rotating solution that does more than deepen a well. It drags the sheet of space-time around itself. In doing so, it opens up possibilities that read like metaphors on paper and like ethical hazards in practice, the prospect of roots that rotation changes everything, where a non-rotating, spherically symmetric hole is a simple sink, an event horizon hiding an inner singularity. A spinning hole is a mechanism with zones and complex anatomy, an ergosphere where space-time itself is compelled to co-rotate outer and inner horizons that separate regions of different causal character, a ring singularity whose geometry allows, in the equations, paths that are not merely forward in time, but curved into closed time-like trajectories. The mathematics seduces the imagination with possibilities, a probe placed carefully, following a precise geometry. That is the theoretical kernel, elegant, compact, and intoxicating. The story grows immediate tension, however, as practical and conceptual complications accumulate. Gravity does not bend to human planning. Space-time geodesics are exquisitely sensitive to initial conditions. A Kerr geometry permits a richer family of orbits than Schwarzschild, including trajectories that skim the ergosphere and plunge toward the ring singularity, where frame dragging is maximal. But the same features that grant the theoretical possibility of closed time-like curves also render any attempt to navigate them precarious. The second layer of risk is dynamical instability. Kerr interiors are not placid corridors that casually permit non-standard causal structures. They house the Cauchy horizon, a surface inside the outer event horizon, beyond which predictability breaks down. In the idealized vacuum Kerr solution, the Cauchy horizon is an analytic feature, but in any physically realistic situation, infalling radiation and perturbations are infinitely blue-shifted as they approach it. What appears as a mild mathematical structure becomes a furnace under physical scrutiny. Mass inflation amplifies into violent cascades of energy density. A third obstacle is back reaction. The Kerr solution is an elegant fixed background on which test particles and fields can be plotted. But real probes are not test particles. They carry energy, mass, electromagnetic fields, and a desire for control. In regimes where closed time-like curves become conceivable, the energy momentum of even small objects can't be ignored. The probe's presence perturbs the geometry. The attempt to manipulate the hole's gravitational field for navigation feeds back into the metric. This nonlinearity undercuts any simple plan to use a Kerr hole as a machine for control. These physical difficulties are compounded by the inscrutable influence of quantum effects at extreme curvature. Quantum field theory in curved space-time, which yielded Hawking radiation and the idea that horizons have temperature and entropy, suggests that semi-classical corrections can become dominant in regions where classical geometry predicts exotic causal structures. Stephen Hawking himself articulated a deep worry, often summarized as the chronology protection conjecture, that nature might protect causality by introducing mechanisms that thwart the formation of time machines. In practice, this could mean that quantum fluctuations, vacuum polarization, or the back reaction. Yet even if one accepts that quantum protection will generally prevent macroscopically traversable time loops, another category of risk remains, one that is subtle and social rather than purely physical. The mere knowledge that space-time allows, in principle, trajectories that return to earlier external time creates a temptation that could reshape cultural priorities. The Kerr hole, as a theoretical time machine, becomes an object of strategic desire, a place to attempt rescue missions into the past, to send messages that might avert catastrophes or to hide records in a temporal pocket. This desire is not merely fanciful. To see the stakes, imagine the sorts of moves that would be proposed in any polity tempted by the idea of temporal engineering. There would be proposals to send probes that broadcast encoded messages to the past, to alter the timeline gently by nudging past events, and to create caches of cultural memory in regions of spacetime that loop back. Each planned intervention carries not only the risk of local physical failure, but the danger of causal ripple effects, unintended consequences that propagate in ways that the planners cannot predict. The history of systems with sensitive dependence on initial conditions warns that even at a deeper level, the possibility of accessible time loops raises foundational questions about identity, responsibility, and legal order. If an agent could, in principle, traverse to an earlier temporal slice and alter events, then accountability across timelines becomes ambiguous. Concepts like causation, blame, and historical testimony would need rethinking. Even if physical protections prevent gross manipulations, merely the prospect would intensify political pressure. Who decides whether attempts to reach the past are authorized? What moral criteria would justify the Kermetical and Natical structures if compelling technical questions were in any way realizable? What would be the destination of a temporal traversal? The Kerr matrix mathematical structure suggests that if one follows the right geodesics deep enough, paths can curve back in external time, but the destination is chaotic and poorly controllable. The mapping from initial conditions, a set of position and velocity parameters at the outer horizon, to the external time coordinate at which the loop reconnects is wildly nonlinear. Slight differences in angular momentum or energy can shift the return point by large amounts. This unpredictability amplifies a crucial philosophical lesson. Access to closed time-like paths, if they existed, would not grant deterministic mastery of history. Instead, they would introduce a form of temporal risk that is uninsurable and socially corrosive. Societies might devote resources to an activity that promises return but delivers only gamble. The whole of threat is thus not only an engineering hazard but an ethical hazard. The lure of retroactive agency could erode institutions, foment greed for control of history, and amplify inequality by scientific prudence adds one more cautionary theme. Even in the speculative models that permit chronology violation in controlled mathematical settings, the presence of entropy and the second law of thermodynamics complicate the notion of closed time-like histories. Any macroscopic attempt to send low-entropy information into the past confronts entropic arrows that resist reversal. The thermodynamic bookkeeping necessary for consistent histories would force restrictions on what, if anything, could be transmitted backward in time without paradox. Attempts to circumvent this by exotic matter or the theoretical community's tentative consensus, if it can be called that, drifts toward caution. The mathematical possibility of closed time-like curves in the Kerr geometry is an invitation to ponder, not a license to act. The physics of perturbations, back reaction, and quantum fluctuations suggests that when one leaves the idealized vacuum solutions and enters the messy reality of matter and measurement, the neat loops tend to fray. Hawking's chronology. Protection conjecture reads like a sober moral. Perhaps the laws of physics conspire to prevent macroscopic causality violations, not by decree, but by the dynamics of. There is a final thread that returns the argument to the human register and to a posture of humility. The twisting geometry of Kerr holes is a reminder that the universe's structural richness far outstrips any one species' capacity to exploit it without patience and humility. The attraction to time machines is not purely scientific curiosity. It is an expression of the most human yearning to fix mistakes, to confer immortality, to preserve memory against entropy. The Kerr solution offers a poetic mirror for that yearning. It shows that the cosmos permits complex structures, ergospheres that can do work. Thus, the whole of threat stands as a multifaceted cautionary image. It is a physical hazard. The inner horizons and mass inflation make the Kerr interior a place of instability. It is an epistemic hazard. Chaos and sensitivity to initial conditions make temporal destinations uncontrollable. It is a social hazard. The temptation to use time-like pathways invites profound ethical and political disruption. And it is a metaphysical hazard. The paradoxes that arise when causation loops back on itself force a re-examination of what it means to. Yet the story is not merely catastrophic. Attending to these dangers deepens appreciation for the patience required by exploration and for the protocols that societies must invent to govern ambitions that reach beyond immediate lifespans. If the most honest outcome is that Kerr holes cannot function as reliable time machines, that conclusion is itself valuable. It folds a piece of cosmic humility back into cultural narrative. It invites a different kind of project, not temporal conquest, but stewardship. The same physics that forbids casual mastery of time also gives. The Kerr black hole, then, remains a profound speculative crossroads. It is a place where mathematics flirts with metaphysics, where rotation converts gravity's quiet insistence into a possible instrument of temporal complexity, and where the gap between theoretical possibility and practical control yawns wide. The narrative tone for a species reflecting on such possibilities is therefore necessarily twofold: fascinated and cautious, curious and sober. The whole of threat marks the moment when wonder meets responsibility. To stare at a spinning maw that hints at looping histories is to confront, in miniature, what if the heart of a galaxy were not only a furnace and a trap, but also a laboratory, a place where the laws of time and memory themselves could be put under a microscope? That quiet, insinuating notion sits at the center of this chapter. At the cores of galaxies, nature assembles the most massive and placidly enormous black holes the universe makes. Objects so vast that their event horizons span light, days or like months, whose gravitational gradients at the horizon are gentle and whose lifetimes exceed the ordinary lifetimes of stars by many, many orders of magnitude. Seen from afar, a supermassive black hole is a paradox of scale and subtlety. It anchors the whirl of stars and gas in galactic centers, sculpts the orbits of star clusters, and, when fed, powers jets that pierce intergalactic space for thousands of light years. But when attention shifts from the dramatic sparks of accretion to the slow geometry of space-time itself, a different role emerges. The region surrounding these behemoths is a natural laboratory for gravitational time dilation and for the study of how information, radiation, and causal influence are reshaped by enormous mass concentrations. Unlike this, observation is the first form of experiment. Humanity's telescopes, radio arrays, X-ray satellites on gravitational wave detectors are instruments at the mouth of that laboratory. Each observational technique reads a different dialect of the same thing: how space-time, radiation, and matter speak near extreme gravity. The shape of a spectral line, skewed and redshifted, tells of photons climbing out of a deep potential well. Rapid variability in X-rays marks the orbital timescales near the innermost stable circular orbit, the slower cadence of variability, smeared by the size of the event horizon. There is an intimacy to that reading. A distant astronomer does not simply collect photons, she reads a chronicle of time's curvature. Flares from the inner accretion disk erupt, then fade, because the material orbiting just outside the horizon obeys a different rhythm. A tiny hotspot circling near the innermost stable orbit will be seen in the variable pattern of light, its rise and fall stretched and Doppler shifted, producing a film strip in which seconds in the local frame correspond to days or years to a distant detector. These signatures are not abstract curiosities, they are the thread through. That observational capacity has consequences for human knowledge and for civilization's self-understanding. First, it sharpens the experimental program. Humanity can contemplate placing clocks and detectors into regimes where relativistic time dilation becomes large without requiring immediate structural annihilation. The thought of tiny probes lingering on stable orbits near the innermost disk, emitting time-stamped signals that climb out to distant watches as stretched chronicles, moves from poetic speculation to a blueprint for robust tests of the interplay between gravity and quantum processes. Even if practicality remains remote, the concept is second and more far-reaching. The existence of these cosmic laboratories reframes strategies for cultural preservation and long-term thinking. Civilizations that imagine deep-time stewardship confront a stubborn fact: the more patient the archive one wishes to construct, the more one must reckon with relativity. Placing physical stores of information into cold, inert vaults is one thing; nesting them in regimes where subjective time runs differently is another. The vicinity of a supermassive black hole, with its ability to dilate external clocks by enormous factors for those who linger close, tempts the imagination as a place. But this seductive option carries moral and practical complications that ripple across societies. To build and maintain near-horizon presences requires an extraordinary allocation of resources and technological mastery. Access becomes a site of inequality. Those with the means might purchase temporal shelter while others cannot. The ethics of such hoarding of time turn longevity into a commodity. Wealth is no longer solely congregated into property and resources, but into years and cultural continuity. Societies that accept or defend against such stratifications must invent legal frameworks, equitable policies, and perhaps a civil. Another consequence is epistemic. The laboratory around a supermassive black hole is not only a place to test physics that might otherwise slide out of reach. Because these black holes live for unfathomably long times, they act as slow burners in the universe's archive. Their accretion histories, the chemical signatures in their jets, all preserve echoes of galactic life over epochs that dwarf human institutional memory. For historians of a future human civilization oriented to cosmological archaeology, the signatures written into the environment of a galaxy's core could become the primary record. That recognition initiates another dizzying set of questions about observation and ethics. If signatures of long-lived civilizations, engineered structures, waste heat, modulated jets were to be sought, then the laboratories at galactic centers provide both opportunity and limitation. Opportunity, because the energy scales and time scales at play might allow certain artifacts to be preserved, scattered, or amplified in ways detectable across interstellar distances. Limitation, because the very processes that grant preservation, accretion, mixing, jet launching, also scramble and transform any signal. Those challenges are also political. Observatories and the capacity to read these subtle signals are institutions in the making. Choices about which regions to survey, whom to train as interpreters of long-term astrophysical archives, and how to allocate the grand bandwidth of telescopes are, in effect, value judgments about what histories are worth preserving and whose questions merit attention. The endeavor becomes not only a science enterprise, but a curatorial politics of cosmic memory. National and supranational priorities, corporate interests, and global publics will contest the stewardship of the. There is also a profound existential dimension to reckon with. The capacity to use supermassive black holes as instruments of time dilation or as sites for deep archival strategies reframes how a species thinks about death and legacy. The urge to preserve and to be remembered, ancient and universal in human cultures, acquires a literal technical avenue. Yet the act of committing cultural memory to such slow frames is also an act of severance. Messages stored near a horizon will not communicate on ordinary timescales. They will be sealed in a very different cadence, making them potentially unreadable to near-term descendants. Deeper still lies the problem of testimony across frames. In all human societies, memory is maintained by shared acts of narration, ceremonies, education, law, repetition. If some actors live at a tempo that slows while the public tempo races ahead, the ability to sustain common stories. For a civilization planning to use supermassive laboratories, the challenge will be to build protocols that translate meaning across tempo divides. Practical solutions: living archives with continual contextualization, layered metadata that anticipates future language. Safety, too, is a sobering consideration. Probing near a supermassive heart, whether for observation or for practical use, entails exposure to extreme energies. Accretion flares, tidal disruption events, and relativistic jets are not merely picturesque, they are violent processes that can alter or obliterate local structures. A civilization investing material capital and human ingenuity into near-horizon enterprises must factor astrophysical risk into ethical calculus. There is a species-level prudence here. The courageous experimenter must weigh the value of a long-lived archive. Finally, the laboratory at galactic centers reframes questions about detection of other minds. If ancient civilizations once walked the cosmos and their large-scale artifacts were fed into a black hole, the observational legacy is ambiguous. A cunningly placed sensor might detect anomalous chemical abundances, peculiar jet modulation, or unexplained patterns in accretion variability. Yet these signals would require extraordinary interpretive caution. Cosmic processes produce patterns that mimic intentionality, and intentional acts may be erased or remixed by the galaxy's engine. The honest stance, the cumulative consequence for humanity, is a philosophical reorientation. Supermassive black holes magnify a truth that runs through every chapter of thinking about deep time. Scale changes everything. When time itself can be tamed, stretched, or escrowed by gravity, ordinary assumptions about continuity, responsibility, and memory must be reconsidered. The laboratory at the heart of a galaxy forces a species to think in vectors of thousands and millions of years, to create institutions that can survive conceptual drift, and to develop an ethic of stewardship for projects whose beneficiaries may be civilizations unheard of. In the end, confronting these laboratories is both a scientific opportunity and a moral test. They offer the most exacting arenas for testing the edges of physical law and the most awkward mirrors for human desires about preservation and legacy. Standing before a supermassive black hole is to face a teacher that is both indifferent and instructive. Indifferent in its indifference to human plans, instructive in the way its scale compels a species to become modest, patient, and inventive. The consequence for humanity is not simply to learn more about gravity, but to learn how to live with long odds, to build practices that value. Listen closely to that quiet laboratory at the heart of the galaxy, and one hears more than photons, one hears a lesson in time. The patient curvature of space-time around supermassive black holes presses a single point with unusual clarity. The future is not merely a sequence to be conquered, it is a shared ecology to be stewarded. In choosing how to engage this laboratory, humanity will reveal whether it can extend its capacity for care beyond the immediate generations to imagine institutions, arts, and ethics that survive the slow calculus of stars and the unavoidable humility demanded by gravity. 11. The temptation of tomorrow. Fast forwarding into deep future. What if the universe offered a way to skip forward? Not by stepping through a fictional portal, but by leaning into gravity's patient arithmetic. That is the provocative idea at the heart of this chapter. Black holes, when treated as instruments rather than merely objects of dread, can act as extreme time machines of a very particular kind. They do not rewind history, nor do they grant return to an altered past. Instead, they promise the possibility of immense future travel. The slow motion of subjective life while the cosmos races ahead, or, in the starkest form, a one-way voyage past a threshold from which no report. The physics that underwrites this temptation is, by now, familiar in outline. Gravity dilates clocks. The deeper the potential, the more stretched the outside world becomes from a local perspective. To live near a massive body, to hover with engines precisely countering the pull, or to orbit just outside the innermost stable trajectory is to choose a different tempo of existence. For those who linger, centuries may be purchased as subjective days. For those who skim and return, the ledger shows an asymmetry, less biological aging, a compressed subjective. There are, however, two practical pathways to fast forward. One is cautious and reversible, to use the gradient of space-time as a temporal currency without crossing the event horizon. Well-designed habitats or probes could hover at radii where time dilation is substantial, but tidal forces remain tolerable. The other is radical and irreversible to cross the horizon, surrendering any comfortable expectation of return on the conjecture that what lies beyond might be a way to a different causal region, or that the inside provides a shelter from the outside. The reversible strategy has a sober engineering face. A civilization that seeks to endure could, in principle, station archival repositories, seed banks, or even low-consumption habitats in orbits where an outside year translates into countless local years. For the cultural imagination, the image is potent, a small, deliberate community choosing to experience time more slowly, to extend subjective continuity across astronomical spans. The practicalities are forbidding, but conceptually clean. Power must be supplied to hover or to sustain orbital altitude. Material must survive high radiation environments. The irreversible option hardens ethical and existential questions into engineering design. To cross an event horizon is to accept absolute causality's closure. Everything that follows is unavailable to outside report. For anyone who values testimony, legal accountability, or the continuity of social obligations, this is a forbidding cost. The decision to cross is not simply a calculation about survival or curiosity, it is the ultimate act of leaving. If civilizations were to mount missions designed as one-way pilgrimages into the interior of black holes, their motivations would be as varied as the human imagination. That sharpness of consequence reframes the question of using black holes as temporal conveyors into a moral economy. Who decides which stories are worth consigning to a one-way voyage? Which artifacts, if any, deserve the wager that their information might be preserved in some scrambled, holographic, or transmuted form? If sending records into a horizon is primarily symbolic, an act of faith in some hypothesized quantum preservation mechanism, then it becomes a ritual for the species, a sacrament of hope that the cosmos, in its own inscrutable bookkeeping, may not altogether erase what it is. There is also a technological calculus that cannot be overlooked. Hovering orbits just outside the horizon are energetically demanding. Maintaining position against inexorable pull requires sustained thrust or ingenious use of orbital mechanics and local angular momentum. Near the photon sphere and the innermost stable circular orbits, radiative environments are brutal. High-energy particles, X-ray fluxes, and magnetized plasmas batter any structure that attempts to linger. Even in the supermassive case, where the horizon is spatially vast and the horizon's curvature gentle at crossing, the surrounding environment. Further complicating the technical ledger is the silent arithmetic of Hawking evaporation and the colossal timescales it invokes. Black holes evaporate by emitting Hawking radiation, but the timescales for massive ones are stupendously long, far exceeding any human planning horizon. If some preservation strategy relies on the eventual dissemination of information via Hawking flux, the beneficiaries are hypothetical auditors in an epoch beyond human institutions. The horizon becomes an archive available, perhaps, only to physics and mathematics. The human emotional texture of such choices is complex and paradoxical. There is, on the one hand, the yearning that motivates the project, a species' desire to stretch its presence into a future that otherwise drifts away, to maintain identity in the face of entropy. That yearning is threaded through grief for inevitable loss, for the passing of immediate peers, for languages and institutions that cannot be carried like seeds. There is also pride, a species-level confidence in capacity, engineering competence enough to park in a deep gravity well, to manage energy flows. This ethical architecture demands institutions as much as technology. Any civilization that contemplates institutionalized time dilation strategies needs governance frameworks that adjudicate what is preserved, who may be preserved, and under what consent. It needs legal norms to account for temporally displaced obligations, for inheritance across frames, for the rights of returnees. if return is even possible, and for the obligations owed to populations that cannot access such technologies. It needs cultural practices that translate across tempos, rituals, continuous retellings, living art. There is, finally, an epistemic humility that must be invoked. Much of the impetus to send artifacts or embassies into horizons rests on hope that information is not absolutely annihilated. Quantum gravity research offers several alluring hypotheses: holographic encodings, correlations in Hawking radiation, or even baby universe routes for causal continuation. But all of these remain at once promising and profoundly uncertain. To commit cultural legacy to a horizon is to bet on theoretical futures as much as on engineering ones. A clear-minded civilization. In the end, the temptation of using black holes to travel into the future is a kind of mirror for civilization. It reveals the species' capacity for patient engineering, its hunger for timescales beyond the crisis of the present, and its persistent willingness to make sacrificial gambits on speculative physics. It also shows ethics and prudence, the awareness that some means of prolongation become forms of abandonment, that monumental gestures can be exercises in hubris when divorced from equitable access, and that the deepest acts of stewardship require patience and institutional humility. 12. Conclusion. The final frontier of time. What is the final frontier of exploration? If, in earlier ages, it was the farthest shore or the highest mountain, and in the industrial centuries it became the globe and the atmosphere, then for a species grown conversant with space-time, the frontier is not merely space, but time itself. To stand before a black hole is to confront a boundary that reframes what it means to travel, not only to navigate coordinates in space, but to negotiate the rates at which existence unfolds. The event horizon, the ergosphere, the inner Cauchy surfaces. These are not just features. The narrative that has run through this account is a patient one. It began with an image, the door of no return, and expanded into a suite of thought experiments, twins aging at different rates, probes that send stretched chronicles, cultures that gamble their legacies into gravitational wells. Along the way, technical subtleties emerged: tidal forces, frame dragging, Hawking radiation, holography, and with them an expanding ethic that knowledge of deep time is inseparable from responsibility toward those who share the present. The central lesson is an austere humility. The universe allows certain manipulations of time. General relativity and quantum ideas carve possibilities into its fabric. Yet those manipulations are not neutral instruments. They recast relations, redistribute obligations, and reconfigure what counts as a shared future. To lean into gravity's offer is to accept new forms of isolation, to place faith in far-off decoding, or to risk leaving the many for the few. That does not mean resignation. Rather, it invites a multi-layered response. First, the scientific work continues: build better detectors, test near-horizon signatures, refine holographic correspondences, and press toward a quantum theory of gravity that speaks plainly about information. Each experimental advance is a promise that the next generation of instruments will read subtler echoes of the universe's bookkeeping. Second, the social work must be done. Develop legal norms for temporal displacements, create robust, distributed archival strategies, and cultivate cultural practices that translate memory across tempos. There is a different kind of courage that this horizon asks for. Not the daring of the solo pioneer who crosses in thrilling isolation, but the patient courage of a society that chooses stewardship by many means. Such courage recognizes that legacy is not preserved merely by physical survival of artifacts, but by the living continuity of practices, retelling, teaching, ritual, and care. It values redundancy over spectacle, translation over hoarding. The imagery that seems most apt to close is not triumphal but generative. Imagine time as a vast, braided river with many eddies and slow pools, some carved by gravity into near stillness, others rushing toward the open sea. Human projects can choose to anchor in a slow pool for a while, to bank memory in a cooled eddy to be reopened later, or to ride the current and speak to the wider flow of history. Each choice is legible. Each has consequences. The black hole is not merely a terminus, it is a decision node in the larger ecology of time management. Finally, there is wonder. Confronting horizons forces a species to feel its finitude and yet to continue the enterprise of curiosity. The paradox is simple and sustaining. To accept limits is not to accept defeat. Boundaries in refining questions sharpen inquiry. The event horizon, the door of no return, both closes certain possibilities and opens others, new languages in physics, new modes of ethical reasoning, and new ways to think communal memory across eons. The proper response is not to seize the cosmos as a dominion, but to enter into a longer conversation with it. So the story ends, for now, on an invitation. The black hole is a frontier not because it yields quick answers, but because it asks the patient questions that will take generations to articulate. The final frontier of time calls for instruments and equations, for laws and rituals, for engineers and archivists, for cosmologists and storytellers. It asks a species to be both inquisitive and careful, to build technologies and institutions that respect the demands of deep time, and to acknowledge that some voyages, those that entail irrevocable crossing, are not merely technical feats but moral acts. What if a black hole did more than swallow mass and light? What if it swallowed the very rhythm by which events are ordered? What if, somewhere beyond the veil, there already sits an ordered life, a pulse that obeys a different ledger of hours, waiting in a temporal register that cannot be compared directly to the one that measures Earth's clocks? The idea shifts the conversation from mechanics to meaning, not merely how space-time curves near enormous mass, but whether that curvature can harbor expectancy. The anxious, patient kind of expectancy that people mean when they speak of waiting. The universe does not speak in metaphors alone. General relativity makes the statement precise: deep potential wells stretch and shear time. For a distant observer, approach to an event horizon is an endless fade. For the local world line, crossing and whatever follows unfold in finite proper time. Those dual accounts are both true and both alien to each other. The question that persists, posed quietly, insistently, by anyone who has ever thought of mortality and memory on cosmic terms, is whether the act of falling into a horizon could ever be, in any meaningful sense, to enter a waiting room. Or to consider the possibility is to reckon with causality and its limits. In the strict classical picture, once a world line crosses the event horizon, it is causally severed from the region outside. The future light cones inside the horizon do not tilt back to reach the outside world. From that vantage, any idea of someone waiting for us inside a black hole is category error. Waiting implies a mutual frame, or, at least, the potential for contact, and that potential does not exist in the standard account. Yet the paradoxes and uncertainties that gather around quantum gravity, information, and horizons complicate this tide. First, there is the indexical sense of waiting. A probe left in orbit near an event horizon, its clocks running slowly relative to Earth's, is in a kind of temporal sequestration. To the outside, its approaches and departures are stretched. To itself, days pass in the usual way. If such a probe transmits pulses outward, the pattern received far away will be elongated and attenuated, the outward-facing archive of a life lived on a different schedule. In this way, waiting can exist as an asymmetric relationship. Something inside a deep potential may be counting and cataloguing, leaving echoes that consider another, more speculative reading. If the interior of a black hole is not a terminal singularity, but a region where quantum effects reorganize the fabric of spacetime, perhaps into a baby universe, a Planck-scale bridge, or a fuzzball of microstates, then waiting acquires literal plurality. Whatever crosses the threshold might find itself in a nascent causal domain with its own flow of time. From the vantage of that interior, external epochs might be incomprehensible, irrelevant, or entirely absent. One can imagine beings or processual continuities, patterns of information that persist in. These thought lanes lead to different kinds of observational hope and practical experimentation. The community of observers on the outside gears instruments to detect what horizons permit them to read. Very near horizon electromagnetic emissions, the subtle modulation of accretion flows, even the patterns in gravitational waves produced by infalling masses. Each can, in principle, carry fingerprints of processes that interacted with matter near the boundary. Scientists design probes and telescopes that act like patient interpreters, collecting data across decades, compressing stretched signals, searching for correlations that betray much. The emotional dimension of this inquiry is not incidental. Humanity's stories about endings and persistence infuse the scientific calculus. The notion that a civilization might have chosen, in some distant past or elsewhere, to send ambassadors into a black hole as a form of deep time insurance is both haunting and understandable. The motivations are recognizably human: grief over entropy, a desire to preserve language and genes, a wish to seed hope beyond the horizon of foreseeable catastrophe. The archival impulse becomes transposed onto a cosmic ledger rather than trusting stone or crystal. A culture might trust deep gravity to slow subject, yet there is a practical counterweight to that optimism. Even if information is not destroyed in principle, even if holographic encodings and subtle correlations in Hawking-like emissions eventually carry out traces of the infallen, the timescales involved eclipse human lifetimes so completely that the gesture might be largely symbolic. A civilization that deposits its cultural records into a black hole and hopes for their eventual outward recovery by distant descendants is placing faith in an audience many orders of magnitude removed from its own. The message, if it ever emerges in a readable form, will do so on a stage that may. The prospect of someone waiting also refracts into metaphors of loneliness and patience that are communal rather than personal. If a probe or an archive ticks slowly at the lip of the horizon, the people who remain outside experience a different kind of waiting: the collective, oriented patience of those who launch projects whose payoffs span millennia. A cultural patience that must be institutionalized through durable scientific bodies, transmitted rituals, and legal frameworks. That social patience is itself an ethical posture, the willingness to build for audiences one will never meet. Observationally, if anyone or any process were indeed waiting beyond a horizon in any sense that could influence the outside, their imprint would most likely be indirect. The classical causal disconnection forbids straightforward correspondence, but quantum and semi-classical processes open softer channels. Information that seems to be lost might be diffused into correlations on the horizon or into entanglement structures that subtly alter the statistics of emitted quanta. Detecting such correlations requires instruments refined beyond current capabilities, detectors sensitive to minute deviations from thermality and background. Philosophically, the question of awaiting presence beyond a horizon presses one to examine what being means when divorced from the prospect of communication. If existence is to be measured by causal efficacy, the power to change what can be observed, then beings behind an event horizon are, by construction, inaccessible and thus outside the scope of empirical reality as ordinarily conceived. But if existence is instead broadened to include patterns of information that persist in any form, then there is room to speak of continued life as structural persistence, as the endurance of complexity even when cut off from familiar. This reconfiguration also reframes the open question the universe poses. Perhaps the more consequential choice is not whether someone is waiting for us, but whether we will invent the patience and humility to listen for the kind of messages that deep gravity makes possible. That listening does not demand immediate triumph. It demands institutions that can steward slow projects, cultural norms that value intergenerational promises, and scientific disciplines that prize patience as a methodological virtue. It also demands imaginative empathy, the capacity to conceive a readership that decodes messages. There is a darker caution as well. The temptation to treat black holes as salvageable vaults could corrupt priorities. If access to more time is made available only to elites, a fate of chronometric inequality, then the impulse to consign cultural memory to horizons might become an inequitable luxury, an asymmetric hoarding of temporal futures. The ethics of such decisions are crucial. A civilization that contemplates horizon-bound archives must grapple frankly with who gets to decide what is preserved and who is permitted to access subjective elongation. Without equitable, finally, there is the possibility that the universe has already answered the question in a way humans cannot easily parse. Suppose, in the grand sweep of cosmic history, some intelligence once experimented with horizons and left inscriptions that have been translated into features of the cosmos itself, into distributions of angular momentum in black hole populations, into chemical anomalies in galactic halos, into modulations in jets. Those traces would be ambiguous and deeply entangled with natural astrophysics. The task of future cosmic archaeologists would be to distinguish between natural noise and intent. In the end, the notion that someone, somewhere, might be waiting in a different time after stepping into a black hole is less a literal claim than a provocation. It forces re-examination of what waiting means when contact is impossible, what preservation means when audiences may never read, and what duty a species has to futures it cannot imagine. The physical constraints are stern, classical causality forbids return, quantum theories complicate the ledger but do not guarantee retrieval, and the timescales dwarf human institutions. Yet the philosophical and ethical questions remain urgent. The final image is not cinematic, but moral. Imagine a ledger written in two inks, the bright ink of immediate, audible history and the faint ink of long, patient deposits into regions where causality thins and time dilates. The bold inscriptions are the familiar archives, books, monuments, recorded testimony, legible to contemporaries and the near future. The faint script is the work of those who bank time, stretched transmissions, holographic encodings, slow vaults poised at the lip of horizons. Both matter. Both are fragile in different ways. To care for one, so the universe's whisper endures. Black holes are not only devourers of matter, they are editors of time. They invite not only fear, but a more patient kind of courage. The willingness to build institutions that listen across eons, to invent languages that outlive personal lifetimes, and to accept that some forms of waiting will be forever private even as they reshape the public ledger of possibility. Whether or not someone sits behind any horizon expecting a reunion is a question the cosmos may never settle for us. What it does settle, over and over, is a demand to reckon honestly